different kind of signals which are shown on your screen. Enable signal, clock signals, VHDL generates, reset signal.
Record किया ना, good. Copy किया.
So we'll talk about all the blocks. Use core generator or the integration first. Any .vhd file, .ngc file, .xco file, we can integrate or interface with this particular IP integration node. Then, as we have seen, we simulate we generate the simulation model. And once you have configured, this behaves like any other LabVIEW FPGA VI in a single cycle time loop. So with this, we'll discuss about the next method, which is called as CLIP, or component level intellectual property, component level IP. Using CLIP also, we do very much similar thing. We try to integrate a third party IP using LabVIEW, and there are some functional difference between the way CLIP works and the way IP works, and we are going to see it now. So again, I'll go back to my LabVIEW VI. So what I'll do is, in my LabVIEW project, under my computers, I have this FPGA target. I'll go to the properties of this FPGA target. I will go to component level IP. Now, and this is how my initial window would look like. To create a component level IP, we'll have to press this button, which is called as create file. Again, a user interface quite similar to the one which we have already seen for IP node will come in front of us. Now what I'll do is, I'll again add a synthesis file. Again add the same VHD file, demo clip adder.vhd. Now it is automatically taken the description name from the file, and then if you want to specify, we can add some IP description as well. I'll say next. Again, this is a window in which we define the entity, architecture, FPGA family type, all these things will define. Again, the same thing, if there are any generics, I'll define the same here. I'll check the syntax in this particular configuration box. Only if the syntax is correct, we will be able to go ahead, or just say next button. Now in this case, again, it has exposed to me all the inputs and outputs along with the clock and reset signal. And here I can see the properties of all of them. Again, if we are using some additional clock in the VHD file, this is where we can configure it. In this particular example, we are not using it. That's why LabVIEW is not showing anything. And once we are done with this, for CLIP, LabVIEW will generate a XML file, and this is what will be the content of that XML file. Now, in our LabVIEW FPGA project, we are going to use this particular XML file whenever we want to refer to the CLIP node. So now, as we can see, we have got a component level IP file path or CLIP file path with description name, its file path. We can add as many CLIP nodes as we want to in any given LabVIEW FPGA project. We'll say OK here. Now, even after saying OK, here we can see that we are not getting anything. That's because we need to include one component level IP under the FPGA target. To do that, we'll again right click on LabVIEW FPGA, we'll say new, and we'll go to the option called as component level IP. And here, LabVIEW will give us a list of all the IPs which we have already initiated. So I'll select demo clip adder. Here in the same window, I can configure clock settings, generates, terminals. for this particular IP. I'll say okay. Again, as I said, we can include as many IPs as we want to as possible. So I've got two different IPs, component level IP and component level IP2, both under the same FPGA target. Now to use this in my FPGA VI, I will right click, I'll create a new VI, and all I have to do is just drag and drop the components I have created or which are available inside my VI. I can use this just like the global variables available with us in LabVIEW and create whatever code we want to create, whatever logic we want to create around this. So in this case, I don't need to worry about the logic or the connection which is going between this inputs and output terminal because I have integrated the code because I have already integrated the same in LabVIEW FPGA project. LabVIEW will take care of everything. So again, as we can see, we have got two fixed point inputs, one output, and whatever value we give to the input, the output will be the addition of those two values. This will happen once we have compiled the program.
एडिशन कैसे
और the LabVIEW
कनेक्ट कर रहे हैं ना बंडल कर रहे हैं concatenate string यूज कर रहे हैं बंडल यूज कर रहे हैं बंडल.
So this is how we can use clip node. Now one thing I would like to point out is that a typical LabVIEW FPGA how it works is there is the host part of the application, there is an IO interface, and then between the two we have a FPGA unit. Now typically there would be a fixed logic which will be there for communication between host connection for host computer, host system and the LabVIEW FPGA VI. There would be a fixed logic for LabVIEW FPGA VI and the IO node communication, and rest part of the FPGA would be taken by the FPGA VI which we are deploying. When we talk about clip node, the VI or the code is deployed somewhat like this, wherein each clip node would run independent of all other nodes and they will communicate with each other as per the logic which we have defined. So if we have defined two different clip nodes, they would run completely independent of each other, and as and when using from LabVIEW VI will call inputs and outputs, we will get the result. So as we have already seen, the implementing steps for clip node is we acquire the IP, we create the XML file. Once we have created the XML file, we add the clip node to LabVIEW FPGA project, and hence we will be able to use it very easily. So with just few clicks, with just few mouse clicks, or with just a few settings, here we are able to use any third-party IP node or any third-party IP inside LabVIEW. Now, when we talk about third-party IPs, these are some of the data types which is supported by LabVIEW FPGA module. So for U8 or I8, LabVIEW, the VHDL type would be STD logic vector 7 down to 0. For U16 and I16, the VHDL type would be STD logic vector 15 down to 0, so on and so forth. If in your VHDL project you have any other data type, let's say STD logic vector 3 down to 0, in that case you will have to make a wrapper class, a wrapper VHD code, which is just converting your custom data into one of the standard data which LabVIEW can understand or LabVIEW can communicate. And as we have already seen, once we have configured everything, all we have to do is just drag and drop, and we would be able to use the clip node inside the VI. Now, this is a comparison table between clip node and IP integration node. It shows what are the data types which are supported, or file formats which are supported. It shows about the clock. So if you see the execution model, it says for clip node, it is parallel as we have seen. For IP integration node, it is inline. What it means is that this will follow the same data flow programming as any other LabVIEW FPGA block. Clip node can be used both inside and outside single cycle time loop, whereas IP integration node, it has to be used inside single cycle time loop. So with this, we have come to the end of today's discussion. I hope I was clear enough to explain the concept. And if you have any doubt, please feel free to tell us. We'll be happy to solve all the doubts you have. Now, for last week's VI contest, the winner is Mr. Jayvan Sakre from Lear Automotive India Private Limited, Chennai. Congratulations, you'll be receiving your goodie bag very soon. And for this week VI contest, it's a very interesting contest in which what you'll have to make is a program, a LabVIEW code, or maybe a library or project in which you'll try to implement a game called as tic-tac-toe. We are all familiar with what tic-tac-toe is. So basically, you have to make a VI in which two users would be able to play this particular game. And LabVIEW will tell us when the game is over or if the game is drawn. I will again repeat it. You have to make a LabVIEW code using which two players can play tic-tac-toe game. Please submit all your entries at webcast.wednesday@ni.com. And today's tip of the week is related to a case structure. So whenever we are using an integer case structure, we can specify a range by giving the input somewhat like this. So if we specify something like 1.5, that means all the numbers between 1 and 5, corresponding to all the numbers between 1 and 5, this particular code would be executed. So if we specify something like 3 dot dot as mentioned there, it will execute the code mentioned there for all the values above 2. With this, we have come to the end of today's webcast. We would like to know about your feedback, so please share your feedback with us. And if you have any questions, please feel free to send it to us at webcast.wednesday@ni.com.